Hello, good morning to all of you. How are you all? I hope you are all doing well today. So, students, today we are going to start a new topic. Okay, that is yes, linear equation in two variable. Okay, so let's start today's class and learn something new. You can see here the situation, students and teachers, the conversation between student and teachers. There are certain number of students and certain number of benches. So you can see certain number of students and certain number of benches are there. Okay, and you can see here when if 3 students sit on each bench, then 1 student will be left. You can see. Okay, and when you can see 4 students sit on each bench, then 1 bench will be left. You can see here. Okay, so the situation are find the number of students and benches in that classroom. Can you find out it? Yes. Okay, so let's try here. Okay, situation 1, 5-star sports. Okay, we have one another situation. So here you can see students, the cost of ball, student purchase, the boy purchasing a ball here. Okay, and yes, now the boy pays rupees 50 for 3 balls. So when he came to house, yes, the cost of 1 ball, can you find out it? Cost of 3 ball and 11 rupees left. Total out of money is 50 here. Okay, so what is the cost of each ball? Can you find out it? Yes, 50 minus 11, that is 39. And number of balls, yes, number of balls is equal to 3. So we can divide 39 by 3. So we get, yes, 39 by 3, that is 13. Okay, so 39 divided by 3, we get rupees 13. That means the cost of each ball is rupees 13 here. Okay, let the cost of each ball be rupees x here. Let's suppose the cost of each ball be x rupees. Then 3x plus 11. 3x why? Yes, number of balls here 3 and cost of each ball is equal to x. So 3x plus 11 is equal to, yes, 50. Okay, 3x plus 11 is equal to 50. That is our equation. Equation means you can see LHS part and RHS part here. LHS and RHS. Okay, left hand side and right hand side. Okay, so that is our equation. So students, linear equation, that is called linear equation. Linear, why linear? You can see here 3x plus 11 is equal to 50. So in this case, linear equation in one variable, you can see here the variable are x here, only one variable. Okay, so linear equation in one variable means, yes, only one variable, consists only one variable x here only. So linear equation in one variable, or we can say simple linear equation. Okay, okay. So 3x plus 11, so we can find out 3x is equal to 50 minus 11, and then 3x equal to 50 minus 11, that is 39. So 3x equal to 39, so x equal to 13 here. Okay, yes, the value of x is 13 here. That means the cost of each ball rupees 13 here. Okay, now we have a one another situation here, Rasid book stall. Okay, you can see now in this situation you can observe here cost of the boys page book and pen. and say similarly the girls pays rupees 50 for 2 books and 2 pens of the same kind. Okay, so here again how much does it cost? Okay, so let's find the cost of pen and each book. So here price of one book and price of one pen. So price of one book is rupees 5 and price of one pen, yes, 32 by 35 minus 5 is equal to 30 and 30 divided by 2 15. So price of one pen is rupees 15 here. Similarly 35 minus 25 is equal to 10, okay, and 10 by 2 that is 5. So price of one pen is equal to 5. When price of one book is 15, so the boy pays rupees 35 for one book and two pens. The boy pays rupees 35 for one book and two pens. Okay, and the girls, let the cost of each notebook be rupees x rupees here. Okay, let the cost of each notebook be x rupees, then and the cost of each pen be y rupees. Okay, cost of each book x rupees, cost of each pen y rupees. So in this case, then you can see here cost of one book plus cost of two pens is equal to 35 rupees. Okay, and here cost of one book, that is x, and cost of two pens, that is 2y. So x plus 2y is equal to 35 here. Okay, so that is a linear equation, x plus 2y is equal to 35. Now x plus 2y is equal to 35. When we substitute the value of uh, cost of one book and cost of one pen, so what will we get? You can see here 520. When the price of one book is 5, then price of one pen equal to 15. When price of one book is 25, then price of one pen will be 5. When price of one book is 15, then price of one pen will be 10. Okay, so there are three situations here. So you can see the graphical representation of linear equation here. You can see, okay, here the graph paper, and you can see the line here, that is the graphical representation of linear equation. Okay, so here you can see the line here and the 3 points 5, 15, 15, 10 and 25, 25, 5, all three situation. Okay, so basically here, yes, 5, 15, 25, 5 and 15, 10. So every situation is point on the line. You can see every situation is a point on the line. Okay, so 25, 5, 15, 10 and 5, 15, all 3 points. Every point on the line is a solution. Every point on the line, student, remember always, every point on the line, in this line, every point, each and every point on this line. And how many points are in a line? Yes, there are infinite points. So every point on the line is a solution. Okay, you can see the number of solution here. Okay, lots of solution. There are infinite points on the line, and yes, there are infinite solution. There are infinite values of the price of one book and the price of one pen. Okay, you can see here that the table here. Okay, price of one book 5, 25, 15, then price of one pen will be 15, 5, 10 and so on. Okay, yes, okay student, now it's question time. I have a question for you. Okay, the general form of linear equation in two variables is ax plus by plus c is equal to 0, where a, b and c are. And I am giving you 30 seconds. So which option is correct here? Option A, real numbers. Option B, 0. Option C, only natural numbers. And option D, none of these. Okay, so let's try it. Which option is correct here? Yes. Okay, time's up. The right answer is yes, option A, real numbers. Here A, B and C are real numbers. Okay. Now let's move the another part. Girl bought 2 books and 2 pens of the same kind of rupees for rupees 50 here. Okay. So the girl paid rupees 50 for 2 books and 2 pens. So in this situation we can yes, we can represent this situation yes, in a linear form. Cost of 2 books plus cost of 2 pens is equal to 50 rupees. So let the cost of by first situation we know that the cost of each notebook rupees X, the cost of each pen be rupees Y. So in this case similarly we can write here X and Y for cost of books and cost of each book and cost of each pen, X and Y. There are two variables here. Okay, so 2x plus 2y is equal to 50. So in this case there are infinite values of the price of one book and the price of one pen. Okay, you can see here again the table. Price of one book, when price of one book is 15, so price of one pen 50 minus 2 into 15, that is 20. Okay, yes, and price of one pen is 10 rupees, and 10, 15, 5, 20 and so on. There are infinite solutions. Okay, so you can see the both situation here. First situation is x plus 2y is equal to 35 and second one is 2x plus 2y is equal to 50, and you can see the table here. Okay, so 15 and 10 is the common solution for the both the situation. Okay, when you observe both the tables, you can see yes, 15 and 10. Okay, 15 and 10. You can see here 15 and 10 in first table and second table. Yes, 15 and 10. So 15 and 10 is the common solution for the both the situation. That means x is equal to 15 and y is equal to 10. So here yes, 15 and 10 is the common solution for the both the situation. We will be able to draw conclusion about the price of book and the price of pen if they are considered together. Okay, so that is the basic point here. Pair, that means pair. So linear equation in two variables. Okay, because here two variables x and y, and pair of linear equation in the same two variables x and y. You can see x and y, x and y. So here both the equations are linear equations in two variables. Okay, and when we say pair of linear equations, that means you can see two equations together, we have two equations, so we can say pair of linear equations in two variables x and y. Okay, and linear equation means, yes, linear equation means the highest power of the polynomial is 1. You can see here the power, the highest power of the x, that is 1, highest power of the y, that is 1 also. Okay, so degree, we can say degree is 1 here. Okay, degree means the highest power of the polynomial, that is 1 here. So we can say linear polynomial, and linear equation in two variables, and here we have two equations, so we can say pair of linear equations in two variables. Okay students, so today we will learn how to solve pair of linear equations in two variables by using different method. Okay, so here pair of linear equations in two variable. You can see here that we have two equations here, x plus 2y is equal to 35 and 2x plus 2y is equal to 15. So two linear equations involving the same variables x and y are said to be pair of linear equations in two variables. Okay, yes, this is the algebraic representation of the situation. Yes, you can see here geometrical representation of this situation. Yes, there are two lines here and both the line intersecting in the one point, you can see. Okay, so here the common solution of both the equations or we can say both the lines are yes 15 and 10. Okay, so both the line intersect at a point, hence there is only one solution for the pair of linear equations in two variables. You can see here both the line intersect only one point. Okay, one and only one point. So there only here only one solution, one and only one solution for the pair of linear equations in two variables. Okay. Okay, now it's question time, students. I have a question for you. Raju bought 6 balls and 2 bats and paid rupees 320. From a linear equation in this regard, take the cost of one ball as x and one bat as y. Okay, so for this question I am giving you yes 30 seconds. Okay, and yes, which option is correct here? Yes, from the linear equation for this particular situation, x plus y is equal to 320, 2x plus 3y is equal to 320, 6x plus 6y is equal to 320 or 6x plus 2y is equal to 320. So which option is correct here? Yes, time's up, student. The right answer is yes, option D. You can see here 6 balls and 2 bats. So you can say cost of one ball will be yes rupees x. Okay, cost of one ball is x and cost of yes one bat, that is y. Okay, so here 6 ball, that means 6x, and 2 bats, that means 2y. Okay, so 6x plus 2y is equal to 320, that is our linear equation. Okay, so the right answer is option D, 6x plus 2y is equal to 320. Okay, so okay, good, very good. Let's move the another part. Now here geometrical representation of the situation. So you can see here the lines are overlapping here. Okay, so how many solutions right now? Can you tell me how many solutions are there? Yes, both the lines are overlapping each other. You can see. Okay, so in this case we have three cases. Two lines in a plane be any one of the following three possibilities. Okay, first possibility is the two lines may intersect at a point. Two lines may intersect at a point only. And second case, yes, the two lines may be coincident. Coincident means yes, overlapping. Okay, overlapping. You can see both the lines are overlapping here. Okay, and third case, the two lines may be parallel. Okay, so here only we have three possibilities. First is two lines are intersecting at only one point, and the two lines may be overlapping or coincident, and third case, yes, the two lines may be parallel. Okay, yes, so the two lines may be coincident. We will discuss about that case. Okay, so here x plus 2y is equal to 35, and in the second case cost of same kind of two books, yes, and 4 pens. So here rupees 70. Okay, cost of same kind of two books and 4 pen is rupees 70. So from the equation x plus 2y is equal to 35, 2x plus 4y is equal to 70. So in this case you can see the linear equation here, pair of linear equation, x plus 2y is equal to 35, that is our first equation. 2x plus 4y is equal to 70, that is our second equation. Yes. So now you can see the graphical representation of line x plus 2y. Every point on the line is a common solution to both the equations. So the equations x plus 2y is equal to 35 and 2x plus 4y is equal to 70 have infinitely many solutions. When we draw the line on the graph paper, so you can see here both the lines are overlapping. That means coincident. Okay, so in this case we can say infinitely many solutions, both the lines have infinitely many solutions here. Okay, so cost of one book and 2 pence and cost of 2 books and 4 pence. So here two equations, taking 2 as the common factor in the second equation. Okay, so 2x plus 2y is equal to yes 70, so 2 into 35, and we can write x plus 2y is equal to 35. So you can see both the equations are same. We get the equation which is same as the first. You can see here first equation and second equation both are same. That means yes, same equation means same line we can draw in a graph paper. Okay, so in this case infinitely many solutions. Both equations are one and the same. Hence the pair of linear equations has got infinite solutions. Okay, yes. Okay students, now it's question time. The graphs of two linear equations is shown below. What is the unique solution of both the equations? So you can see the graph, and yes, I am giving you 30 seconds. So which option is correct here? Option A 4 1, option C 2 4, option C 4 2, and option D 5 3. Yes students, times up. The right answer is yes. You can see here both the line intersecting at one point only. Okay, you can see the point. So unique solution of both the equations. So you can see here the points are the coordinates of this point. Yes, you can see x axis, that is 4. Okay, and y axis, yes, that is 2. So the coordinates of the common points are 4 comma 2, 4 comma 2. That means our answer is 4 comma 2, that is option C. Okay, yes, okay, good. So option is right answer is option C here. Okay, now let's move the another part, geometrical representation of the situation. So here the geometrical representation of particular situation here. Okay, so here you can see both the lines are parallel in this situation. Both the lines are parallel. That means yes, no common point between two lines here. So in this case the two lines may be parallel. Okay, so okay, let's see the situation here. Cost of one book and 2 pens is rupees 35, and we have another situation, cost of one book and 2 pens, that is yes rupees 50. So you can see here there are different costs. One book and 2 pen is rupees 35, and similarly one book and 2 pens is rupees 50 now. So in this case x plus 2y is equal to 35 and x plus 2y is equal to 50. So let us represent this situation graphically. Okay, let's see. So x plus 2y is equal to 35 and x plus 2y is equal to 50. So here student, you can see the graphical representation of both the lines. Okay, so in this case you can see the lines do not intersect at all. Okay, this means that the pair of linear equations in two variables has no solution. Okay, because yes, there are no common point between two lines. That means yes, they have no solutions. Okay, so in both the both the pair equation, linear equations have no solution here. Okay, so that is our third case. So remember always, the pair of linear equations may have unique solution when two lines intersecting each other. That means yes, we have a unique solution that time. Second case, the pair of linear equations may have infinitely many solutions. Yes, when two lines overlapping each other. And the third one, yes, the pair of linear equations may not have any solution. That means the lines are parallel. Okay, so in the third case, the lines are parallel. In the second case, lines are overlapping. And first, yes, lines, yes, intersecting each other. Okay. Okay, students, now it's question time. I have a question for you. The graph of a pair of linear equations in two variables are parallel straight lines. Then the given pair of linear equations has, and I am giving you 30 seconds. Okay. So which option is correct here? Option A, B, C and D. Unique solution, no solution, infinitely many solutions and none of the above. Yes. You can read the question carefully. Okay, linear equation in two variables are parallel straight lines, parallel straight line like this. Okay, parallel straight line. So okay, student, time's up. The right answer is yes, linear equation, no solution. When the yes, linear, you can see parallel straight line, that means no solution. So remember always, okay, parallel straight line means no solution here. So right answer is option B. Okay. Okay, let's move the another part. So yes, the seed book stall and Nayak book stall, x plus 2y is equal to 35 and 2p plus 2q is equal to 50. So in this case, suppose if Rajni had purchased different kind of books but not of the same price, then how do we represent them algebraically? Can you tell me? As you can see here, x plus 2y is equal to 35 and 2p plus 2q is equal to 50. So in this case, where x, y represent the price of book and pen in one shop, and p and q represent the different price of the book in and pen in the another shop. So in this case, here you can see x plus 2y is equal to 35, 2p plus 2q is equal to 50. So are these pair of linear equations in two variables? Yes or no? Yes, not a pair of linear equations in two variables. So remember always, pair of linear equations means same variables in the both the equation. Okay, suppose x and y in first equation, so x and y will be second equation. Okay, if p and q in second equation, so p and q in first equation also. So we can, that time we can say it's a linear equation in pair of linear equation. But you can see here different variables, so that means yes, not a pair of linear equation in two variables. Okay, so analysis of the three situations. Okay, situation 1, you can see here the unique solution, 15 and 10 is the common solution for the both the situations, and x is equal to 15 and y is equal to 10. In the second situation, x plus 2y is equal to 35 and 2x plus 4y equal to 70. So in this situation, you can see here the graphical representation of both the lines are yes, these lines are overlapping here. So in this case, there are many solutions, infinitely many solutions. Okay, consistent pair of linear equations. Okay, and that is independent, and you can see here In the second case, that is dependent. Okay, so independent and dependent. Independent means yes, unique solution. Dependent, you can see here both the lines are overlapping. Situation 3, when we have equation x plus 2y is equal to 35 and x plus 2y is equal to 50. So you can see here both the lines are parallel here. Okay, so in this case, yes, 5, 22.5, 25, 12.5. So you can see here in this case independent. Okay, so consistent means unique solution and infinitely many solution. When we say consistent, that means unique solution and infinitely many solution. Okay, and inconsistent, so inconsistent means no solutions. Okay, so remember always consistence, that means yes, unique solution, and infinitely many solution, and inconsistent means no solution. Okay, now it's question time. Which of the following represents is inconsistent pair of linear equations in two variables? Okay, and yes, I am giving you 30 seconds. Now option A, intersecting lines, option B, parallel lines, option C, coincident lines, and option D, none of the above. So which option is correct here? Yes, time's up. The right answer is option B. Okay, inconsistent means yes, parallel lines, no solution here. Okay, so the right answer is option B, parallel lines. Okay, now let's move the another part. Represent the following situations algebraically. So here the cost of 3 dosa and 4 idli is rupees 160. The cost of same kind of 5 dosa and 3 idli is rupees 230. So here we represent this situation, yes, algebraically. So you can see cost of 3 dosa plus 4 idli is equal to rupees 160, and 5 dosa and 3 idli, that is rupees 230. So in this case, yes, represent the following situation algebraically. We have another situation. The cost of 2 kg rice and 3 kg sugar is rupees 180, and the cost of same kind of 3 kg rice and 4 kg sugar is rupees 300. So here cost of 2 kg rice plus 3 kg sugar, that is rupees 180, and yes, second equation is 3 kg rice plus 4 kg sugar, that is rupees 300. So we can write 2r plus 3s is equal to 180 and 3r plus 4s is equal to 300. So now general form of pair of linear equations in two variables. So let's see the general form. You can see here x plus 2y, 2x plus 2y, okay, and 5x minus 6y, and you can see 3x minus 9y, 7x plus 2y, or 3d plus 4i, or 2r plus 3s, 3r plus 4s. So you can see both the all the examples here. So in this case we can write just like this, 3x minus 8y minus 50 equal to 0. Okay, write RHS, we can write 0. Okay, so RHS, yes, and you can see the last equations, 2r plus 3s minus 180 equal to 0, and yes, so here 3r plus 4s minus 3 and equal to 0. So that is, we can write the general form now. Okay, so here the general form x plus y. Okay, and for the coefficient we can write a1 a2, and second coefficient we can write b1 b2, and yes, third one, the constant term, we can say we can write c1 c2. So that is a1x plus b1y plus c1 equal to 0, and second equation will be yes, a2x plus b2y plus c2 equal to 0. So here the general equation of the pair of linear equation in two variables. Okay, now students, it's a value based question. You ate chocolate, and after you finish eating, what will you do? Throw the wrapper in the dustbin and throw it on the road or anywhere around you. Okay, so I'm giving you 30 seconds. Yes. Throw the wrapper in the dustbin and throw it on the road or anywhere around you. Okay, student, time's up. The right answer is yes, option A. Throw the wrapper in the dustbin always. Okay, remember always. Okay, so yes. Now, student, let's summarize what we have learned today. Okay, so today, yes, the graphically representation of pair of linear equation in yes, pair of linear equation in two variables. So we have three situations. One is yes, that means intersecting lines. Yes, option that is intersecting. Second, yes, parallel lines. Okay, parallel. And third one, yes, third one is overlapping line. Okay, overlapping. So consistent, that means consistent lines are yes when intersecting, and yes, no solution, that is parallel lines. Okay, so overlapping, yes, there many solutions. So overlapping and intersecting, that means in this case when lines are intersecting, that means unique solution, and when lines are overlapping, that means infinitely many solution. So in the both the case we can say consistent. Okay, consistent lines. And in the when the lines are parallel, that means inconsistent lines. So remember always the three cases. Okay. Okay, now okay, it's a feedback question. How do you feel? Okay, and I'm giving you yes 25 seconds. Happy, quite good, satisfactory, or confused? So today we have learned how to represent the situation in graphically and algebraically. Okay, so we will learn in the next class how to solve yes linear equation in two variables. Okay. Okay, student, time's up. So it's over the it's time to over the class. I hope you enjoyed today's class. Keep practicing. Okay. Okay, then bye bye. Take care. See you in the next class.